AI predicts an earthquake in fundamental physics. Quarks have a full electric charge instead of one-third or two-thirds as the standard model states. Here is why. Annihilation according to SM. According to the standard model, the annihilation of an electron and a positron gives two photons. But this equation flagrantly violates the law of conservation of matter. To remedy this, we must add a neutrino, nu. Neutrino modeling. We deduce from this nu equal to an electron minus a photon plus a positron minus a photon. So the neutrino nu is composed of an electron having lost its main photon and a positron having lost its main photon. We know that the neutrino has a very low mass. This allows us to assume that the electron and the positron each have a residual photon. Question: how does the new pair behave? Static or dynamic? This question will give rise to a new model of fundamental particles. Another non-standard model. Another model named Xijidong, abbreviated as XM. XM will describe the details of the following: elementary particles, the neutrino and its family, quarks, nucleons. This will allow us to show the relevant characteristics of the XM model. XM, elementary particle. There are only two following elementary particles: the photon and the electric charge. The photon plus and the photon minus. We know a photon has a rotation. If the rotation is in the right-hand direction, it will be noted as polarity plus. Otherwise, it will be noted as polarity minus. XM, structure of an electron. A pure electric charge, Co minus, becomes an electron by capturing a photon, Zhong minus. XM, structure of a positron. A pure electrical charge, Co plus, becomes a positron by capturing a photon, Zhong plus. XM, structure of a neutrino and its family. In XM, a neutrino is composed of an electron and a positron. The electric force animate the two particles with, in equilibrium with the the electron and the position are in rotation. V is the rotation speed. In XM, this structure is called a charge net. And there are different energy levels for the charge net, depending on the V, the rotation speed. The rotation of the charge net reveals electrical neutrality. This rotation also gives its properties a disk-like appearance. XM, structure of an up quark. In XM, three charge nets form a stable triangular chain. This stability is ensured by the electric force at the three contact points, which are three vertices of the triangle. The green charge net has an orbital speed of 3v. This structure with a position in the center is the up quark. This combined particle has an electric charge of E+. In XM, this position-free structure is called chrominate up. This combined particle is electrically neutral. XM, structure of a down quark. In XM, three charge nets form a stable triangular chain. This stability is ensured by the electric force at the three contact points, which are three vertices of the triangle. The blue-orange charge net has an orbital speed v. This structure with electron is the down quark. This combined particle has an electric charge E-. In XM, this electron-free structure is called a down chrominate. This combined particle is electrically neutral. XM, structure of a neutron. Starting with the up quark called the core that has three sides. The construction continues with the same principle as a quark on its three sides. We obtain a neutron. There are two down quarks and one up quark at the edge. This electrical balance is 2E- plus 2E plus equal to 0. XM, representation of the neutron. The neutron has an axis of symmetry that passes through the center of the core and is parallel to the three charge nets of the core. The view along this axis can be represented by the diagram opposite. XM, structure of a proton. Starting with a down chrominate called the core that has three sides, the construction continues with the same principle as a quark on its three sides. We obtain a proton. There are two up quarks and one down quark at the edge. The electrical balance is 2E plus E minus equal to E plus. xm representation of the proton. The proton has an axis of symmetry that passes through the center of the heart and is parallel to the three charge net of the heart. The view along this axis can be given here. XM, interaction between quarks. Interaction between the quarks of a nucleon is electric. This interaction is structural. The core of a nucleon is an up quark or a down coordinate. But here, the coordinate is treated as if it were a quark. The core of a nucleon is a quark, an up quark or a down quark. Each of the three quarks at the edge is built on a rib of the core. This Siamese structure makes the three quarks of the nucleon inseparable. The core of the nucleon is a fourth quark, which allows for the following two configurations. All quarks have an electric charge. This is the case of the neutron. Only quarks at the edge have an electric charge. This is the case of the proton. All this rehabilitates the fractional electric charges of quarks. For more details, you can see useful links for given here. https nonstandardmodel.org, http jax.dom.free.fr.